Good morning, everybody. Today, actually, I'm going to start the basic understanding of electromagnetic wave and with derivation of the wave equation in free space as well as medium and different possible solution of the wave equation. And this understanding of this wave equation and different parameter associated with the electromagnetic wave, specifically electric field, magnetic field, propagation vector, and is very important in order to understand communication also, in order to understand electromagnetic wave in waveguide, transmission line, optical fiber optics communication, and so we have to understand everything from the differential wave equation. Okay, so that is why I'm going to start first start the wave equation in free space. First wave equation in free space, wave equation in free space, wave equation in free space. So what is the wave equation in free space? We have to understand. So in order to tell the derive the wave equation in free space, I am focusing first Maxwell equation. Maxwell equation. What are the Maxwell equation? Number one, divergence of E equal to minus rho by dt. 2, divergence of D equal to 0, tini del cross E equal to minus del B by del T, and number 4, del cross B equal to mu J plus mu del D by del T. These are the 4 Maxwell equation. So Maxwell equation is nothing. First equation is derived from Gauss divergence law, static and electrostatic, and it is the first order differential equation, and source term is this term is source, epsilon naught is constant, rho is a source. So this is the first order inhomogeneous differential equation, but this is also this is derived from magnetostatics. It is first order differential equation, and B the homogeneous equation, there is no source term. It does meaning of this equation, magnetic monopole does not exist, but electric monopole exists because right hand side is non-zero. And this equation is derived from Faraday equation, and this is Ampere's modified theorem, and this is the displacement vector term. Okay, this is known as the displacement current density. Okay, but in case of free space, what happens? In free space rho is equal to 0. Number 1. Number 2, if rho is equal J equal to rho V or any VD, and EVD, and E is the size, N is the density, V is the deep velocity, equal to 0. Okay, and mu equal to mu naught, epsilon tends to epsilon naught. This is the parameter. So wave equation in free space, so this term will be 0 and this term will be 0, and another term displacement vector epsilon naught. So you can write mu naught epsilon naught. This is the wave Maxwell equation in free space. Okay. Maxwell equation in free space. Okay. Now in order to derive, you see, in order to derive wave equation means it is the relation between in order to derive the wave equation in terms of electric field, in terms of magnetic field, you can take any one of these 4 equations. But here this is there is no, here is electric field, but there is no magnetic field term, and here is a magnetic field, no electric field term. This equation and this equation is more reliable to derive the wave equation, because electric field is there, magnetic field is there, magnetic field is here, electric field is there. This is E. Okay. So now if I take curl of any equation, curl of equation number 3, suppose I take the curl of equation, you can take curl of equation number 4 also, no problem. So it will give del cross E, that is in left hand side, equal to minus del cross del B by del T. Is it okay? Now now if you remember, I remove this part of it. If you see in the, this is what the del is a vector, so it is a vector triple product. Have you seen this vector triple, A cross B cross C? And if you want to see, you can see chapter number 1, David Griffith book, page 18. Okay, if you see the David Griffith book, page number 18, you will find that vector triple product. Scalar triple product is also there. Scalar triple product means it is a volume. So vector triple product formula: B into A dot C, C into A dot B. This is not the, this is the formula. If you expand same way, then you will find del del E minus del square E equal to, this term will, this term is no relation with delta, so you can take it outside. So this term equal to 0 as per Maxwell equation. So this equation E equal to minus minus cancel. So if you put this value here, this value, if you put it here, then you will get minus mu naught epsilon naught del square E by del D square. So minus minus cancel. So you will find del square E equal to mu naught epsilon naught del square E by del D square. Okay, or I remove this part. Finally, what I am getting, so finally first equation, that is D equal to 1 mu naught epsilon naught del square E by del D square. Similarly, if I take the curl of equation number 4, you will get, I am not going to derive that part, I am simply write mu naught epsilon naught del square B by del D square. It's nothing, just replace E by B. From where we can get, if you take the curl of equation number 4, you will get this equation. These two equations are wave equation in free space. Okay. Now, now simple. This equation means I can generalize this equation like this: del square F equal to 1 by mu naught F naught. Mu naught epsilon naught del square F by del D square, where F equal to E and B. I generalize this equation. Okay. Now mechanical wave equation, classical wave equation. If you see the classical equation, you will find del square F equal to 1 by V square del square F by del D square. This is the classical wave equation. If we compare this, okay, you no need to remember, it's just equation number A1. This is equation number A2. This is a classical wave equation. So if you compare equation number 1 and equation number 2, then V equal to 1 by mu naught epsilon naught under root of is, this is equal to, represent equal to C. This is velocity of light. In velocity of light 2.97982 into 10 to the power 8 meter per second. Okay, this is the velocity of light. Now problem is that because this is V square, there will be two possible solutions. Okay, two possible solution means solution of the wave equation, general solution of the wave equation. Suppose if I generalize this equation, simply generalize this equation like that, of course F equal to and 1 by C square, so del square F by dt square. Don't confuse, F means it may be E, it may be B. Okay, the general solution, so I will take F is equal to Kx minus Bt, suppose one solution, and F Kx minus, this is 100 Bt, and F equal to, this is 1 to T equal to, this is third solution. Suppose third solution is equal to F1 Kx minus Bt plus F2 Kx plus Bt. This is also solution. This represents electromagnetic wave. Suppose this is a source of electromagnetic wave propagating along x-axis. Okay, this means electromagnetic wave. This means this is a source electromagnetic propagating along this axis F2. This is F1. Okay, and third one, suppose this is source electromagnetic wave propagating along this section and this direction, it is represented by Ft. Okay. Now, now this is the basic things. Now our requirement is that the solution of the wave equation. What is the solution of the wave equation? Now solution of the wave equation. Solution of wave equation. What type of solution? Wave equation, etc. Solution of the wave equation always in phasor form. E naught e to the power I k dot r minus omega t. This is in phasor. Similarly, B equal to B naught e to the power I k dot r minus omega t. This is a three-dimensional solution. Okay, why it is three-dimensional? Why it is three-dimensional is that this is a three-dimensional solution because k equal to kxi plus kyz plus kz k. This is similarly r equal to xi yj plus zk. This is a three-dimensional solution and it is a phasor forms. And what does the meaning of solution? Because any differential equation, if you solve any differential equation, you will get a, if we plot the wave function, solution of any differential equation, you will get a curve. Okay. Similarly, is if you see in quantum mechanics, quantum mechanics will always encounter differential equation. This is the Schrödinger equation. E minus V phi. Okay, this is the second order Schrödinger differential equation. Okay, our aim is to find the solution of the wave equation. Suppose if I get the solution of the wave equation, a to the power I k x minus omega t. So according to quantum mechanics, according to postulate of quantum mechanics, any quantum mechanical system, suppose one is Hazarika or maybe one electron, is represented by the wave function. Okay, and second step, we have to find the wave function. Once we know the wave function, once we derive the wave function, this is the wave function, it is derived from Schrödinger equation, then behavior or nature of the particle or system of particle can be characterized by the wave function. If we analyze this wave function, we can get all necessary information about the behavior of the particle or system of particle associated with this wave function. Similarly, in electromagnetic wave, if we analyze the solution of this first second order differential equation both in position coordinate and time coordinate, these are the solution. If we analyze this solution, we can characterize the behavior of the electromagnetic wave in particular medium. So what if we find the electric field, if we find the magnetic field, if we energy associated with the electromagnetic in terms of electric field and magnetic field, if we calculate, then we can easily characterize the behavior of electromagnetic wave. That is why understanding of solution is very, very essential. Okay, this is three-dimensional solution. Two-dimensional solution, if I write a two-dimensional solution, okay, I can write this is in two-dimensional solution, I can expand like this, kx x plus ky y plus k, this is y minus omega t. Similarly, b equal to b naught, this part remains same. Okay, why this two-dimensional solution? K equal to kx, k equal to kx I vector, ky j vector, and r equal to xi plus yj. If you take the dot product, then you will find this. This is two-dimensional solution. And one-dimensional solution, simply we write one-dimensional solution. E naught e to the power, suppose along k axis omega t. B equal to b naught e to the power I kx minus omega t. Now you try to interpret. This is, first of all, this is the phasor solution. Phasor means, suppose Bragg-Hussein criteria, oscillator Bragg-Hussein criteria, product of open loop gain and feedback gain equal to 1. This is a Bragg-Hussein criteria in electronics. Okay, but if I write in phasor form, I can write e to the power alpha. Is it okay? This is the criteria of oscillator, and this is the criteria of oscillator. And phi value, for what value? It is either 0. If phi value is 0, then it will be 1. And if it is pi twice pi, then cos twice pi plus I sin pi, it will be twice pi means 360 degree. Okay, this is the possible angle. Or you can see, if you cos e to the power I phi, if I take the modulus cos phi plus I sin phi equal to 1. Is it okay? That means phasor is a mathematical simplified function. Okay, it does not have physical meaning. Only for mathematical simplicity we often use in the phasor form. But whenever we do calculation, or if we derive any parameter using this function, we always consider the either cos term or sin term. Cos term means this is if you see this equation, then b naught equal to cos x cos kx minus omega t plus I sin kx. Suppose if you want to do calculation, you take this part only, or you can take b naught sin kx only. If you take cos part, then your result, and if you take sin part, then in that case also result will be same. Only there is a difference of phase in between sin and cos 90 degree. Okay, this is the phasor. This is the trigonometric function. This is the phasor form. You can express any terms of. Okay. Now relation between we have already seen that there's a three possible term, and the relations between electric field, magnetic field, and propagation vector. These are the three important terms in electromagnetic wave. Okay. Three possible terms in electromagnetic wave: electric field, magnetic field, and propagation vector. Electric field, it will be, these are the already vector. K is also vector, propagation vector. It will give the information about the direction of propagation of electromagnetic wave, as well as wavelength associated with the wave vector, electromagnetic wave. Now my aim is here is that what is the relation between electric field, magnetic field, and propagation direction. Okay. I have to establish this relation. Before that, I want to give you important point one. See, I want to give you short tricks how to remember the formula, because we don't know we cannot remember all the mathematical formula and terms. So that's why I'm giving you short term. See, once you know, see, divergence of E equal to, if I take one-dimensional solution, suppose one-dimensional solution E equal to E naught e to the power I k x minus omega. This is the electromagnetic wave electric field of wave equation solution, one dimensional. And what is the value of divergence of E equal to dE by dx? Is it okay? Then divergence of E equal to, if I take the derivative, then what happens? E naught e to the power I kx minus omega t d by dx I kx minus omega. Is it okay? Then it will be k, I k will come. It will be e, this whole term will become e, and I k. Is it okay? Now if I cancel e, so divergence equal to I k. Is it okay? Short term. So no need to do anything. Divergence is always replaced by I imaginary number into k vector. Similarly, if I del equal to, I have already find out I k. This is a short term. How to reduce your time in exam. So similarly, if I take the del E by del t equal to how much? If you take the derivative with respect to time, a whole term will come out E naught I kx minus omega t. Okay, then minus I omega. Is it okay? And this is become e into minus I omega. So so first important relations, important point one, that is del is always equal to I k. Remember, once I find del, I will replace del equal to I k. Similarly, if I take the del t, see, again I am telling you del E by del t. Del E by del t equal to E naught e to the power I kx minus omega t minus I omega. So this part will become the e into minus I omega. So e cancel. So del t equal to minus I omega. Okay. So del t equal to, I will directly put minus I omega. Or if it is minus, or if we replace minus I k, then del t equal to I omega. Okay. These two important is really important point to do. Number one. Okay. Now second time I am going to find the relation 1. Relations 1. First relation I am find out. So from the Maxwell equation, divergence of E equal to 0. See, del equal to Ik into E equal to 0. Is it okay? That means K is perpendicular to E. Is it okay? Similarly, second equation, if I look back the second equation, divergence of B equal to 0. Then this means Ik into E equal to 0, B equal to 0. That means K is perpendicular to B. Okay, from this equation we can conclude that K is perpendicular to E, perpendicular to B. What from relation 1 I can understand that in electromagnetic wave, 3 possible variables, that electric field, magnetic field and propagation the vector, all are mutually perpendicular to x, perpendicular to each other, like Cartesian coordinate system x, y, z. Okay, that is relation number 1. Relation number 2. Relation 2. What is the relation 2? Is suppose I want to find out the relation between electric field, propagation vector and the magnetic field. So you can take any equation. I will take del cross E equal to minus this is a Faraday equation or Maxwell equation, third Maxwell equation. So I have already given you short tricks. Del equal to Ik into E equal to minus del equal to I omega into B. Is it okay? Minus minus cancel. So K cos E equal to omega B. Is it okay? This is the vector rules. Have you remembered that this formula A cross B equal to C? Okay, what is the meaning of this equation? That A cross B equal to C, that means C is an area vector. This area vector is perpendicular both B as well as A. Similarly, for a particular electromagnetic wave, omega is constant. Particular electromagnetic wave frequency is constant, omega is constant. Forget about omega. It may be you may consider it is 1. So B is area vector. B is perpendicular both electric field as well as magnetic propagation vector. That means their behavior is look like that. If it is propagation director K vector, this is E vector, magnetic field will be like this. So it is look like a rectangular coordinates axis. Okay. So I have already derived that K is perpendicular to E. That means angle between KE equal to, because this formula you know, A cross B equal to AB, magnitude of A, magnitude of B, sine theta, n cap. Unit vector. So this is 90 degree. This is 90 degree because they all are perpendicular. I simply write KE in magnitude form omega B. Okay. Omega B. So what is the meaning of this equation? B equal to KE by omega. Okay. This omega means K means twice pi by lambda and E, and this is twice pi nu. So if I cancel it is E by C. This is the relation between electric field and magnetic field. Okay. So in free space, the what relation I am getting in free space, B magnetic field is written as this is the relation in free space. But in medium, B we have to replace E by V. V is the velocity in medium. This is the relation in this is in free space. This is in particular medium. Now forget about the medium. Now we focus on the free relation between in free space. So what does it mean? The meaning in magnetic field, magnitude of in electromagnetic wave, magnetic field is C times smaller than electric field. Okay, C times smaller than electric field. That is why when we talk about the polarization of electromagnetic wave, we often talk about the polarization of electric field. Polarization, not polarization of magnetic field, because magnitude of B is C times smaller than electric field. So conventionally, suppose, have you remembered this equation? I don't know. I think you have remembered. This is a polarization equation. E y square B square minus twice ex ey ab cos delta equal to sine square delta. This is the equation of polarization of electromagnetic. Ex means electric field. So polarization of electromagnetic wave means polarization of electric field. Okay. If you see David Griffith book, if you see David J. Griffith books, 379 page 379, and figure number 9.10. If you see, this fact is already they have written, but a mathematical reason they have not explained. They have written as by conventionally polarization of electromagnetic wave means polarization of electric field, but not polarization of magnetic field, because of this reason. Okay. Second point, this is the relation. But in case of medium, we have to B equal to E by V. Okay. Now V is the velocity of light. Suppose in that case, refractive index we have to introduce. Refractive index means C by V. Okay. C means velocity of light is constant and V means velocity of medium. So what does it mean? Refractive index means it is a constant value. Refractive index is a constant value. It will give information how fast electromagnetic wave move in a particular medium. For example, suppose refractive index N1 equal to C by V1. It is 1.5. Suppose this is a medium water, and this is a water medium, A medium. Okay, and another effective index C by V2 equal to 1.0. Suppose in medium B. Okay. What does it mean? So 1.5 means V is smaller because C is constant. So higher effective index means lower velocity of electromagnetic wave in medium 1, and lower effective index means high velocity of electromagnetic wave in that medium. So this is how refractive index is characterized. So refractive index will tell you how fast electromagnetic wave propagated in a particular medium. Clear? These are the important facts we have already studied. Now, if we do the calculation, see, if we do one or two calculations, suppose now coordinate relations. So these will help you understand the mechanism of electromagnetic wave, how it moves. See, in Cartesian coordinate system is represented by what? X cap, Y cap, or you can Z cap, or IZ. You can write IZ also. This is Cartesian coordinate. This is suppose spherical coordinate system, R theta cap, phi cap. Is it okay? And this is cylindrical coordinate system. This is clockwise, R cap, phi cap, Z cap. But in electromagnetic wave also follow the same behavior. This is E cap, electric field unit vector, B cap. This is K cap, unit vector, or S cap. Same rule follow all four coordinate system. Here, suppose if we take the cos y equal to x, y, it will be Z cap. Or if we take the anti-clockwise, y cap into x cap, it will be minus Z cap. Similarly here, R cap into theta cap equal to phi cap. Here also same rule follow, R cap into phi cap equal to Z cap. Similarly, if we take the here electric field unit vector into B cap equal to K cap. Okay, K cap or S cap. Similarly, if we take anti-clockwise direction, B cap into E cap equal to minus K cap. The same rule follow all four coordinate system, and this will help you to understand the direction of electric field and magnetic field. Okay. And all remaining property, then I dot B equal to how much? I dot B equal to non-zero, and E dot E equal to 0. A cross product is 0. Cross product is this. If we see that I dot Y, X dot Y equal to how much? 0, because theta is 90 degree. Similarly, E dot B is 0, I have already told you, and E dot B dot K is also 0, K dot E is also 0. It will follow the same rule like a coordinate system. This is how you can remember. Now if we do one or two problem, then you can easily understand numerical problem. See this question number one. Question number one. Okay. See, if electric field is E is equal to Z at T equal to E naught e to the power I k Z minus omega T x k. This is the solution. Then find what is the value of B. This question comes in the net or GATE exam, and if we solve numerical problem, then you can easily understand the behavior of the electromagnetic wave. Okay. Now see, solution is very easy. Okay, I have to find out B. This equal to B naught as per standard solution. Standard solution equal to E naught e to the power I kx minus omega t. B is equal to B naught e to the power I kx minus omega t. This is the standard solution. Now this B equal to B naught e to the power I kx minus omega t. I have to find out. Now before that I am writing in terms of E. Okay, I will write E equal to E naught. Now do not confuse, because k vector is associated with the x. That means k propagation direction is x cap, or you can say I cap also. Okay, do not confuse. And this x is direction of electric field vector. This is z. This is z. Z means it is propagating along z axis. Okay, k vector. Clear? And this E is associated with the x. That means E is along x cap, or you can say I cap also. If we see this diagram, electric field, magnetic field, and propagation direction or pointing vector. Now what is the value? I have to find out B. So B means I have to take the cross product of K into E. So B equal to unit vector of B equal to K cross product of E. So K is propagating direction along K cap into E propagating direction I cap. K into I cap means what? C I J K. K into I cap means C. It is J cap, or you can say Y cap also. Okay. So what you can understand, B equal to B naught. This part will remain fixed, this part will not change, exponential term, and this will be y cap. Okay. Now B naught is not here, so how can you calculate? Because I have already derived this relation. B equal to E by C. Is it okay? It is free space, in free space. Okay. Then B I have to replace E naught by C. This part will exponential part remain same, kz minus omega t. This part will be y cap. This is the solution. Nothing to do anything. Okay. This is how we have to find out. Another solution, suppose. Another solution. I strongly suggest you to read the electric field book. Another suggestion is, suppose if electric field, question number 2, if electric field ERT is equal to E naught by C cos K dot R minus omega t plus delta is a phase shift, don't worry, K vector into n cap. Find B and B vector. This question comes in the net exam, so it is very easy. Solution is very easy. So this part will remain fixed. Only we have to find out the direction. Now what is the direction? See, wave vector is propagating, because this is a 3-dimensional solution. The wave vector is associated with x, r. That means wave vector propagating along k direction. You have to write like this: E vector, E cap, B cap, K cap, or S cap. Now this is C. E is already given. Direction of E vector is this one. So direction of E vector, unit vector, is this one, K cap into n cap. So direction of propagation vector is propagation vector is k cap. It is not begin. It is 3-dimensional. That means it is along all 3 directions. This is simply write as a k cap vector. So what is the? I have to find out b. B means what? We have to do clockwise. So b equal to unit vector equal to k cap into e cap. So k cap e cap means k cap into n cap. Simple. So it is look like I have already told b cap c equal to this is the vector triple product b a dot c minus c a dot b. This is the formula vector triple product. This is b, this is c. Then you will find equal to b means k equal to a means k cap dot n cap minus c n cap, then a dot b n cap k dot k. Okay, so finally you will get n cap. Finally you will get n cap. This is a vector triple product. You see the focus. So magnetic field vector, I will get the n cap. A cross b equal to a dot c. I have already given that formula. And another problem, numerical problem, b dot a dot c. So n cap. So b solution equal to, I have already given b solution, because b naught, this cos part will remain same and equal to n cap. Okay, and b equal to e. This is e naught by c. So b equal to only how much? b equal to e naught by c. E naught by c is already given. So it will be b naught, and cos term this solution. Cos. Okay. This is the solution. This is very easy. Now, secondly, I will focus on the energy of electromagnetic wave. Energy of EM. Energy of E and B in EM. So, in electromagnetic wave, electric field is main component is electric field and magnetic field, and another third component is k vector. K vector only give the propagation, nature of propagation. Okay, so we have to focus only two variable: time dependent electric field and time dependent magnetic field. Now my question is that how much energy? So in electromagnetic wave, energy associated with the electromagnetic wave, how much energy shared by electric field, how much energy shared by magnetic field, that's what we have to know. Okay, but although magnitude of magnetic field is c times smaller than electric field, but energy shared by electric field and magnetic field are equal. This information is very, very essential. Whenever we see, for example, whenever we send a electromagnetic signal from one point to another point, suppose source to destination through a guided medium or optical fiber, then we have to know how much energy lost during the transmission. Okay, during transmission throughout the channel, we have to know. For example, signal to noise ratio, we have to know. So that is why, and another important thing, electric field vector as well as magnetic field vector depend on the channel medium through which the electromagnetic wave propagated. So first of all, we have to calculate the energy shared by electric field, magnetic field. Probably you have remembered electric field energy is equal to 1/2 integration E dot d displacement vector dv. I assume that you have already seen this equation is already given in the previous electrostatic chapter. Okay, d is the displacement vector, E is electric field. But in case of free space, d equal to, I have already told you, epsilon naught E in free space. So E dot epsilon naught E dV. So A dot A, this is A dot A, like A dot A means A square. Similarly, E dot E epsilon equal to 1 by epsilon naught E square will come out. Integration of dV means V. This is the energy of electric field. And then energy density of electric field UE by V equal to half epsilon naught E square. This is the energy density of electric field in electromagnetic. This expression is using this in calculation of energy density in electromagnetic. This is the density. Okay. Similarly, if we see the magnetic field energy, of magnetic field, we have to calculate same formula, B dot H dV. Okay, and B equal to mu naught H. So if I take this equation, similarly previous equation, mu naught B square V. So energy density, so magnetic field energy density 1 by 2 mu naught B square. Clear? This is the energy formula that we are going to use in order to calculate the energy associated with electric field and magnetic field. Okay. Now, now suppose we are going to calculate the average energy. This is the formula. 1 by 2 epsilon naught E square. This is the magnetic field energy 1 by 2 epsilon naught B square. Okay. Now if I take the electric field is equal to E naught I kx minus omega t. So I cannot use this formula here. Then I have to convert this equation in trigonometric function. E naught cos kx minus omega t plus I sin kx minus omega t. Now I get this is the real part. This is imaginary part. This means real of E, okay, plus I imaginary part of E. You can take this part, you can take this part, answer will remain same. So real E means real part E naught cos kx minus omega t. Similarly imaginary part this means. Okay. Or I can, so I simply take the real part. I assume that electric field in trigonometric form is equal to cos kx minus omega t. Or if you want, you can take E equal to E naught sin kx minus omega t. Result in this case will remain same. So energy density mu E equal to half epsilon naught, then E naught square cos I take cos kx minus omega t. Is it okay? Similarly, magnetic energy equal to 1 by mu naught. This is E naught by c square. C square there is a relation. So cos square kx minus omega t. Is it okay? These are the this is the relation 1A1. This is the instantaneous. A2 is the instantaneous energy. Okay. Instantaneous. Now average energy. Average energy. In ACES you have already studied AC power, DC power, voltage, ripple factor. So RMS value. So whenever AC current is I equal to I naught cos omega t, then this is the instantaneous current. So in that case we have to calculate the average energy, average power, average current. Okay. So average relations, how can you calculate average relation? So average velocity, average energy, this is a constant term. You cannot take the average of constant term. This equal to gamma E naught square. Is it okay? Then cos square kx minus omega t. Okay. Similarly, magnetic energy, average magnetic energy 1 by mu naught E naught square c square cos square kx minus omega t. Okay, and now see, if if you take the sine part, then it will be sine square, it will be sine square. Now now how can you take the average value? You have to remember the average formula. Average formula is this one. Okay, 0 to t dt integration 0 to t ft dt. Is it okay? This is the average formula. Or in terms of theta, you can write 0 to twice pi d theta, 0 to twice pi. Okay, 0 to twice pi f theta d theta. This is the formula. So if we take the average of cos function, any function, theta suppose, it will be L equal to sin theta value equal to 0. If you put this value, you can say I am not going to do. And now if it is sine square, then it will be sine square, it will be sine square, average value is half. So average of cos square, any function, whatever it is, equal to half. Average of sine square, if you do the calculation using formula, I am not going to do, is very easy, half. Okay, another way you can remember, since sine square theta plus cos square theta equal to 1, okay, sine square plus cos square theta equal to 1, so average value of sine theta, average of sine square must be equal to half. Similarly, average value of cos. So using that average value, mu energy, average energy is equal to, this equal to half 1 by 4 E naught square, square, this is average of magnetic field is equal to 1 by mu naught E naught square C square, this is 4. Now if you see C equal to 1 by C square equal to 1 by mu naught epsilon naught. If you put this value, you will get 1 by 4 epsilon naught E square. That means energy equal to energy B. Okay, so that means I am stopping here. That means in electromagnetic wave, total energy is equally shared in between electric field and magnetic field. Clear? So in the next class, I will discuss the Poynting vector, which is important. Poynting vector measures the total energy flux. Okay, S is a Poynting vector, total energy flux coming out from a particular source toward the destination. Okay, after this part, thank you. So if you have any question, if you have any doubt, you can send me SMS. Just you try to understand the nature of electromagnetic wave, how we represent the electric field and the solution, and what is the physical meaning of each equation we have to understand. Then we can easily understand communication, waveguide, transmission line, and optical communication, fiber optics communication, we can easily understand. This is the basic requirement. And another important thing that I have told you, that whatever the solution I am writing here, this is the Cartesian solution. And this because whenever we talk about the communication or propagation of electromagnetic wave through a cylindrical pipe, okay, then we have to take the solution of the wave equation in a cylindrical coordinate system according to the problem defined. Then we have to understand the solution of electric field and magnetic field, which are the solution of wave equation in coordinate system. In the next class, we'll discuss how coordinate system is related to describe the behavior of electric field and magnetic field through a particular medium. We will discuss later. Okay, thank you. I hope you understand. These are the basic information, and through which you can easily understand the remaining part that are associated with the waveguide and transmission line. Thank you.